So welcome back to College Algebra. Excited to see you guys again. And today we are going to look at quadratic equations, solving quadratic equations. We started with that at the end of last week, but we're going to continue looking at different methods of solving quadratic equations. And then we're going to get into the complex number system. So let me share my screen with you. So before I start in the notes, I just wanted to show you really quick that under your week 2 module, you'll see class notes for chapter 1. These are fill-in notes, and I may or may not use these. I'll try to use some of it today. I will use some of it today, but I will be supplementing more information into the class notes if we do use them. So you can grab them from here, if you can print them off if you'd like. So let me get into our screen. And so last week we ended off with the square root method for solving quadratic equations. We can only use this method if we have a certain form, and I'll show you in a little bit how we can get this form if it's not in this form so that we can use this method. But the square root method says if we have some x squared equals p where p is greater than 0, then x is equal to positive square root of p and the negative square root of p. So if we want to solve a square root using the square root method, we want to isolate our square. And so first thing we want to do is we want to isolate that perfect square. And so for part A, where we have x squared minus 7 equals 0, all we're doing is adding 7 to both sides. So we get x squared is equal to 7. Take the square root of both sides to get x. So we get x is equal to plus or minus the square root of 7. So similar idea for the next example. We have a perfect square in here, x minus 4 quantity squared. The other terms outside of that perfect square don't have an x. So we can isolate that perfect square by adding 9 to both sides of our equation. So in this case, we would get x minus 4 quantity squared equals 9. Taking the square root of both sides, I'll put plus or minus in front of the 1. And I always tend to do it just in front of the number of the square root. So the square root cancels out the square. We're left with x minus 4 on the left is equal to plus or minus square root of 9 is 3. So in this case, because this is a whole number, let's write this as 2 separate equations. We have x minus 4 equals positive 3, and we have x minus 4 equals negative 3. So adding 4 to both sides, we get x equals 7. Adding 4 to both sides, in this case, we get x is equal to, well, negative 3 plus 4 is positive 1. Okay, so the square root method is a lot faster than if we had solved this by expanding. So A, I couldn't have done that, but part B, and I just want to show you because there's a lot of times there's multiple methods that you can do to solve these quadratic equations, but being able to look at it and notice which way is easier is very helpful. It can save you a lot of time. But if you didn't realize that you could use the square root method here, we would have had to expand this x minus 4 quantity squared. So we would have had to look at x minus 4 all times x minus 4 minus 9 equals 0. And now if I distribute, so distributing this x to each term, in the second parentheses, I would get x squared minus 4x. Distribute the negative 4 to each term. So I get negative 4x. Negative 4 times negative 4 is positive 16. Then minus this 9 equals 0. Combining like terms. So the only like term, well, I guess we have multiple ones. So there's no other x squared term, so let's bring it down. We have a negative 4x minus 4x is a negative 8x. We have a positive 16 minus 9, so this is plus 7 equals 0. So quadratic, we would want to, in this form, I would see if it's factorable, what multiplies to give me my constant 7 and adds to give me my middle coefficient of negative 8. This is the easier way to do it because that coefficient in front of the x squared is 1. So those are easier to factor if they're factorable. So what multiplies to positive 7 and adds to negative 8 is negative 7 and negative 1. So x minus 7, x minus 1. So it's factored, it's equal to 0. So we can use that 0 property and set each factor equal to 0. X minus 7 equals 0 and x minus 1 equals 0. So x is 7 and x is 1, which is what we got before. But notice how much faster, I can get the screen not to do that, it was to use that square root method. So let me see if there's any questions on that. And then if there's not, we're going to jump into how to complete the square. And completing the square, we could get this into the form so that we can use the square root method. So let me see if I can find the pause button. Okay, so let's say now that we want to get a quadratic equation. So let's write out what the generic quadratic equation looks like. So ax squared plus bx plus c is equal to 0. And we want to put it in the form so that we can use the square root method. In order to complete the square, our coefficient in front of the x squared has to be 1. So we're going to derive, we're deriving. Well, I'm going to get to this point, but I'm going to we're deriving the quadratic formula by completing the square. So first thing that we need is 1. The coefficient a needs to equal 1. So since I have this generic form in front of me, ax squared plus bx plus c equals 0, stipulation a can't be 0 or it's not quadratic. And I don't know if that coefficient is 1 or not, but we can make it a 1 by dividing all terms by a. So if a is not 1, we're going to divide every single term on both sides of the equation by a. So a doesn't equal 1. Divide both sides of the equation by a. Okay, so doing that, I would have ax squared over a, which simplifies down to x squared, plus, well, we don't know if they're common factors between b and a, so we're just going to write it as b over a times x plus c over a is equal to, well, 0 over a number that's not 0 is 0. So once we made sure that that coefficient in front of the x squared is 1, if it wasn't already 1, then the next step is let's get the constant to the other side of the equation. So remember, the constant was the number that wasn't associated with the number in front of our variable, our letter. And in this case, our variable is x. So get the constant to the other side of the equation. So we're going to subtract c over a on both sides. So if we subtract c over a on both sides, that's going to give us x squared plus b over a x. I'm going to leave a little bit of room here, is equal to, I subtracted c over a. And so we've isolated our variables, got our constant to the other side. And then our goal is we want to add some number that would make this left-hand side, the side that I have the variables, a perfect square. So we want to find and add the number on both sides of the equation. Right? If we do something to one side, we got to do it to the other. That would make the one side a perfect square. So part of me wants to, let's stop here for a second and kind of think about what we need to do to add to make something a perfect square. And so let's actually look at a couple of examples before we do this with just variables and no numbers. So let me just kind of pull in an example in here. So let's say we want to find the number that would make, how about x squared plus 6x a perfect square. So we're trying to find something that we're going to add here. So, and what we're adding, well, we need it to be the same number that we would add to get 6. And this number that we're adding, we're going to square that number. So what is the same number that I can add to get 6?
Three, right?
Right, so 3. So 3 plus 3 we know is 6. And so we know that constant is, we take those factors that we use to add to get 6, we multiply them together. So 3 times 3 gives us 9. So in this case, we would have to add 9 to both sides, right? Because x squared plus 6x plus 9, we could rewrite as a perfect square. X plus 3 times x plus 3, or x plus 3 quantity squared. So if we had x squared plus 20x, and you're thinking to yourself, what am I adding here to make that a perfect square? So same number that adds to give us that middle coefficient. So basically, what are you doing to get that same number that you're going to add to get that middle coefficient each time? But it's always going to be half of that number. So 10 plus 10 is 20. And then 10 times 10. So we know that number that will make this trinomial perfect square, we would have to add 100. So x squared plus 20x plus 100. which is factorable as x plus 10 times x plus 10, or x plus 10 quantity squared. So to figure out what that number is, to add to both sides of the equation, basically you're looking at your b value, you're taking half of that, and then you're squaring it. Okay, so let's go back to driving that quadratic formula where we just had variables in here. So this is saying I'm taking this value in front of my x, which in this case is b over a. I kind of want to do this on the side. Let me just look at this. So b over a. And we're dividing that by 2. So another way to think of that is b over a times 1/2. So multiplication fractions multiply straight across. So we get b over 2a. But it tells me that I want to square this. So remember, when you're squaring fractions, you're squaring both the numerator and you're squaring the denominator. So if I square b, I get back b squared. And if I square 2a, well, 2a times 2a, that gives me back 4a squared. So this is the number that's going to make the one side a perfect square. And so I want to add this to both sides of my equal sign. So I'm going to add b over a on both sides. I'm sorry, b squared over 4a squared on both sides. So this side right now, we just manipulated it, and a lot of mathematics is manipulating things to fall out how we want it to. We just manipulated that to be a perfect square. So we're looking at the same thing that we would add to give us b over a. Well, that's b over 2a plus b over 2a gives me 2b over 2a, which reduces to b over a. And so it's x plus b over a quantity squared. Something's wrong. And this should be 2a. Sorry, b over 2a. And then if we square b over 2a times b over 2a, we get that constant here. So this is equal to, well, let's write this one side over here. Let's get a common denominator. Let's combine as one fraction. And so I noticed that my LCD of those two fractions is 4a squared. And so I noticed then to get a perfect square, then I'm going to need to multiply this one side, or this one fraction, negative c over a. To get that common denominator 4a squared, I need to multiply the top and bottom by 4a. Okay, so this one side, I'm just going to write the b squared first. I have b squared. 4a times negative c is minus 4ac. All over our common denominator of 4a squared. Okay, so we just manipulated this so that we have a perfect square. So we figured out what that number we needed to add to both sides of the equation was to make the one side a perfect square. You're going to rewrite the one side as a perfect square. Which we did. And now it's in the form that we can use that square root method. So now use the square root method to solve. Okay, so we're taking the square root of both sides. So when we're taking the square root of that square cancels. And so on the left-hand side, all we're left with is what was inside the parentheses, the x plus b over 2a equals, taking the square root, we need to put that plus or minus in front, the square root of the right-hand side, which is b squared minus 4ac all over 4a squared. So if we have a radical and we have a fraction inside the radical, we can rewrite it as the square root or the radical of the numerator all over the radical of the denominator. So rewriting this, I have x plus b over 2a is equal to plus or minus the square root of the numerator, b squared minus 4ac, all over the square root of my denominator. Notice if I take the square root of 4a squared, well, that would just give me back 2a. I'm almost there. I just need to get x by itself. And so we can get x by itself by subtracting b over 2a. Notice when I subtract b over 2a on both sides, we have a common denominator. So we can write that as one fraction. And so then we get x is equal to subtracting b over 2a, that would give me negative b over 2a, but combining it as a single fraction, I get negative b plus or minus the square root of b squared minus 4ac all over 2a. So showing you steps on how to complete the square, ended up deriving the quadratic formula. Quadratic formula is always going to work for solving solutions for quadratic equations. So sometimes we'll look at and try to factor and it won't factor. Then we would jump in and we would use the quadratic formula, or we would use the completing the square method. Completing the square is something that you want to get down. We're going to be using completing the square method over and over in this class as we go on. It's just a method, a type of thing that we do in mathematics to help us solve certain equations. And when we get into our conic sections, which are circles or ellipses or parabolas or hyperbolas, we're going to use that completing the square method to help us put things in a certain form so we know how to graph them. So let's go through multiple examples of solving some equations by completing the square. So I just mentioned when the recording was off that completing the square is just a really important method that you learn how to do, and it's something that we'll be using over and over in this class, and you'll be using in other classes. And so normally when you're taking a test and I ask you to solve equations, I probably would just say solve these equations. I wouldn't tell you what type it is. And normally I wouldn't tell you which way to solve it, except for maybe completing the square method. I might ask you solve this quadratic equation by completing the square, just to make sure that you have it down. Okay, so first thing that we want to do, part A, let's look at A, which is this x squared plus 6x plus 5. We want the coefficient in front of our x squared 1, and it is. So we're good there. The next thing that we want to do is we want to isolate the terms with our variables. We want to get that constant to the other side. So we want to subtract 5 on both sides. And we would get x squared plus 6x. I'm going to leave a little space here. We're going to add something to this. Is equal to, we subtracted 5 on both sides, minus 5. But we're going to add something to the other side. So we want to add it here too. So plus whatever we decide to add. So we're trying to find the number that we can add to make x squared plus 6x plus that number be a perfect square. So we looked at half of that coefficient in front of the x. So half of 6 is 2, and then square that number, which is 9. So we're going to add 9 to both sides of our equation. So now let's rewrite the one side as a perfect square. So the same number we would add to itself to get 6 and multiply to itself to get 9, that's 3. So x plus 3 quantity squared is equal to negative 5 plus 9, which is 4. So it's in the form now that we could use the square root method, taking the square root of both sides. We get x plus 3 quantity squared. The square root of that is equal to plus or minus the square root of 4. So you get x plus 3 is equal to plus or minus square root of 4 gives us 2. So either x plus 3 equals 2 or x plus 3 equals negative 2. So subtract 3 on both sides, we get x equals negative 1, or x is equal to negative 5. Something's off. The reason why I'm saying something is off is because if I add negative 1 and negative 5 together, I am not getting positive 6. I'll just pause for a second. Okay, I don't know why I'm questioning myself. I'm right. Okay, so here we go right here. And I'll show you why in a second. So notice here, we could have solved this equation totally differently and it would have been so much faster if you would have looked at x squared plus 6x plus 5. This is factorable. So the two numbers that multiply to positive 5 and add to positive 6, that's 5 and 1. So the factors are going to be x plus 1, x plus 5 equals 0. And then when we set each factor equal to 0 and solve for x, that's where I get the opposite sign that I was of the factors. So this would give me x equals negative 1 and x equals negative 5, which is the exact thing I got using the square root method. Okay, so part B, looking at completing the square on the example, 2x squared plus x minus 3 is equal to 0. So this is a case where our coefficient in front of the x squared is not 1. And so we want to make that 1 by dividing all the terms on both sides of the equation by 2. And so now we get x squared plus 1/2 x minus 3/2 is equal to 0. So let's isolate all the terms with the variable x and get the constant to the other side. So if we do that, we get x squared plus 1/2 x is equal to, I'm going to leave a space there, adding 3/2 to both sides. So we're going to get equals 3/2. So this is where it's a little harder because our coefficient that we're trying to half is a fraction, but it's not too bad. And if you need to just write it down and do it on the side, that's okay. So we're looking at b over 2 quantity squared. And so in our case, this is 1/2 divided by 2 quantity squared. Or think of it as 1/2 divided by 2, division with fractions. We take the first fraction times the reciprocal of what you're dividing by, which is 1/2. Quantity squared. So 1/2 times 1/2 gives us 1/4. So, and then we're squaring that. So we get 1/16. So we're adding 1/16 to both sides of our equation. So this number that I would add to itself to get 1/2 is always going to be this number in here before you square it. 1/4 plus 1/4 gives me 2/4, which is 1/2. And then 1/4 times 1/4 gives me that number we just found, which was 1/16. So this one side we can rewrite as a perfect square as x plus 1/4 quantity squared equals, well, in order to add 3/2 and 1/16, in order to add fractions, we need a common denominator. So my common denominator of 2 and 16 is 16. So let's multiply this moment, this 3/2 by 8 over 8, a fancy one, to make that denominator equivalent to the other fraction. So we really have 24/16 plus 1/16. So 24/16 plus 1/16 gives me 25/16. So it's in the form now, we can use that square root method. Well, taking the square root of a square, that cancels out the square. And we're just left with this x plus 1/4 on one side. And then taking the square root, well, 25 and 16 are both perfect squares. So this is going to give me plus or minus 5/4. If it helps you write it out as two separate fractions, we have x plus 1/4 equals positive 5/4. And x plus 1/4 equals negative 1/4. I'm sorry, not negative 1/4, negative 5/4. Add or subtract 1/4 on both sides. Well, 5/4 minus 1/4 is 4/4, and 4/4 is just 1. So if I subtract 1/4 from negative 5/4, this actually gives me negative 6/4, but I want to reduce this. So this is negative, 2 goes into both 6 and 4, so negative 3/2. So a little more difficult when that coefficient in front of the x squared is not 1, and then having to deal with our middle term not being a fraction is a little harder, but it's doable, and I know you can do it. Okay, so we're going to look at one more, and this example we're going to solve by both completing the square and using the quadratic formula. And in this case, we have 3x squared minus 5x minus 7 equals 0. Let's do completing the square first. And so solving by completing the square, we know that we have to make that coefficient in front of the x squared a 1. And so we can do that by dividing all the terms by that coefficient in front of x squared, in this case is 3, to both sides of the equation. So if we divide every single term by 3, this would give us back x squared minus 5/3 x minus 7/3 equals 0. Get the constant to the other side. So x squared minus 5/3 x. I'm going to leave a spot so we can figure out what we're adding to both sides. Space equals adding 7/3 to both sides. So 7/3 plus whatever we add to the other side to make that a perfect square. So again, I think it's a little harder when we're dividing by, we're figuring that out when that b value is a fraction. So negative 5/3 divide by 2 and square. Or negative 5/3 times 1/2 and square it. So this gives us negative 5/6. And squaring that gives us 25/36. So this is the number we want to add to both sides of the equation. So this one side should now be a perfect square. And it's always this right before we square it. So it's going to be x minus 5/6. And we can always check. So negative 5/6, adding it to itself, minus 5/6. This gives us negative 10/6, which reduces down to negative 5/3, which is what we had up here. Okay, so it did work out. And negative 5/6 times negative 5/6 is 25/36. So this is equal to, well, we need to be able to add fractions together. So figure out what the least common denominator, our LCD of 36 and 3 is equal to 36. So we need to multiply 7/3 by a fancy 1 to get 36 down in that denominator. And that fancy 1 will be 12/12. So I can't just do this in my head as fast. So that's 7/14. That's 84 plus 25 all over 36. So take the square root of both sides. I'm going to sum the numerators first. 84 plus 25, that gives me 109 all over 36. Taking the square root of both sides, I get x minus 5/6 equals the plus or minus the square root of the numerator all over the square root of the denominator. Let's just write it like that. And so now let's add 5/6 to both sides. And we get x is equal to 5 plus or minus the square root of 109. Square root of 36 is 6, so we'll have the same common denominator. I'm just going to make this as one fraction, all over 6. If 109 had a factor that was a perfect square, I would rewrite it and pull out what I could from the square root. But it doesn't, and so this is as far as we can take it. Okay, so that was completing the square. Quadratic formula is so much easier. So let me just teach you. And I might be slaughtering it a little bit, but this might help you memorize the quadratic formula if you don't already have it down. And so quadratic formula, remember that could be in the form of, I'm sorry, the quadratic equation is in the form of ax squared plus bx plus c equals 0. And we can find the solutions by just plugging in our coefficients, the numbers in front of our variables or in the constant into this equation. Okay. So here is maybe a way to memorize it, maybe not. Just like, please excuse my dear Aunt Sally stands for parentheses, exponents, multiply, divide, and order appears. In addition to subtraction, order appears for order of operations. So here we go. A negative boy, so negative b, he couldn't decide, so plus or minus, to go to a radical party, so square root, or b squared, and lose out, so minus, b squared minus, 4 awesome chicks, so 4ac, all to be over at 2 a.m. So 2a. Okay, so a student taught me that many, many years ago at Yuba College in one of my classes, and I thought that was really cute. So I've used that. So negative boy couldn't decide if to be radical. Sorry, a negative boy couldn't decide if to go to a radical party or b squared minus and lose out on 4 awesome chicks all over to be over at 2 a.m. Okay. So let's pull that equation back that we had before. Before our equation, that was 3x squared minus 5x minus 7 equals 0. So all you're doing is you're identifying which coefficient is a. So in our case, a here is 3. Which one is b? So our b coefficient is -5. And our c value, so carry your signs with these. So our c value is -7. So all I'm doing is I'm going back in here and plugging in my numbers. So negative of b, so negative of -5, normally I would just write 5, plus or minus square root. I'm squaring b, which is -5, minus 4 times a times c. So a was 3, c is -7. All over 2 times a, so 2 times 3. So we're using order of operations to simplify the numerator. Negative of -5 is +5, plus or minus the square root. So -5 squared, that's 25, minus, multiplication comes first. But I have a -4 times a +3, that's -12, and -12 times a -7, we saw that was 84. So really plus 84 all over 2 times 3, which is 6. And so just simplify underneath the radical. We get 5x equals 5 plus or minus the square root of 109 all over 6, which is the exact same thing that we got up here. So I think the quadratic formula is easier, personally, if you have your equation formula down. So I wanted to go over a couple other things with the quadratic equations and solving. So let's just, I'm jumping into some of those notes that you can fill in that I had posted on Canvas. And we did talk about the quadratic equation, but I want to go formula, but I want to go in a little more depth with that. So consider the quadratic equation. We know it's in the form of ax squared plus bx plus c equals 0, where a can't be 0. We saw that the solution to that quadratic equation can be found using the quadratic formula. And that quadratic formula again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The quantity, so what's underneath that radical, which is b squared minus 4ac, this is called the discriminant of the quadratic equation. Okay, so b squared minus 4ac, this is called the discriminant. This discriminant, this number, tells us what type of solution we're going to have and how many we're going to have. So if the discriminant, if b squared minus 4ac is greater than 0, there's, wait, sorry, I just need to read what they say. Okay, so if our value b squared minus 4ac is greater than 0, it's a positive number, then we're going to have 2 unequal, and they're going to be real solutions. If we find that our value b squared minus 4ac equals 0, then we're only going to have 1, and it's going to be a repeated solution. If we find the value underneath the radical b squared minus 4ac is less than 0, that means we have a negative underneath our radical, which is actually an imaginary number. And so in that case, we would say that there's no real solution. Okay, so that really to me makes sense, because that we're looking at what's underneath that radical. If that's a positive number, then we're going to really get this negative b plus or minus the square root of that positive number all over 2a. So that's giving me 2 separate answers. If what's underneath the radical is equal to 0, well, when I look at negative b plus 0 or negative b minus 0, that's the same number. And then if it's less than 0, I have negative b plus some imaginary number over 2a, and then negative b minus some imaginary number over 2a. So those are not real solutions. So right now for the homework, when you're going through this piece, this section of the homework, when you get a negative underneath the radical, you would just say no real solution. After we talk today about complex numbers, then you would give the solution as a complex number. Okay. So procedures for solving the quadratic equation. Well, we've already done this. To solve the quadratic equation, we first put it in standard form, and that was the, oops, let's get up here, not a highlighter. That was the ax squared plus bx plus c equals 0. Okay, identify, I guess I'm guessing on what this is not my form that I do it, so I have to look at it, sorry. Identify our coefficients, so A, B, and C. We want to evaluate the discriminant, which was that b squared minus 4ac. If the discriminant is negative, we know that the equation has no real solution. If the discriminant is 0, then the equation has one real solution. And if the discriminant is positive, the equation has two real solutions. And they're unique. So it's just telling you if you can easily spot factors, use factoring method to solve equations. So that's the fastest, easiest way to solve if it's in that form of ax squared plus bx plus c equals 0 and it's factorable. And you can see those factors, then factor it. That's the best way to go. Otherwise, you're going to use the quadratic formula, or we're going to complete the square. Okay, so we have a quadratic equation in front of us. 2p squared plus 5p minus 4 equals 0. And we want to find how many solutions or what type of solutions and how many this will have. And sometimes that's all we want to know. Maybe we don't even want to know or care about what the solutions are. And this will help us sometimes when we're going through and graphing equations later on in this course. Is it going to cross the x-axis or not? Is there a solution, a real solution? Okay, so let's find the discriminant. And so our a value is 2, our b value is 5, and our c value is -4. So just make sure that you're carrying the sign in front of the coefficients. And then our discriminant is b squared minus 4ac. We want to see, is this positive, 0, or a negative number when we do this? And so our b value, we're going to plug in 5, we're going to square it, minus 4 times a, so plugging in 2, times c, which is -4. Right away, I can see that this is bigger than 0 just by seeing that -4 times 2 times -4 is positive, and 5 squared is positive. So, but let's just do it anyways. 5 squared is 25. -4 times 2, that's -8, but -8 times -4, that's positive 32. So summing these up, I get 57. So since 57 is greater than 0, we know that there are two real solutions. So it doesn't tell me what my solutions are, it just tells me that there are two real solutions. And so if I wanted to find those real solutions, I would either have to see if I can factor this, or I would complete the square, or I would go in through and use the quadratic formula. And right away, just looking at our AC method, 2 times -4, that's -8. And I can't think of two numbers that multiply to -8 and add to 5. Because the only thing that multiplies to just 8, let's just talk about 8, is 1 and 8 and 2 and 4. And summing those together is never going to give me back a positive 5. And so I know that that's not factorable because I couldn't find those two numbers. And so personally, I would go through and I would use the quadratic equation if I had to find the solutions. And so let's just do that real quick to do one more example, and then we're going to move on to complex numbers. So I know P is equal to plus or negative B. So negative B is 5 plus or minus the square root B squared, so 25, minus 4. Well, we actually found this. Oh, actually, we can save some work, right? We just found B squared minus 4AC. So let's just go in here, and that's the square root of 57 all over 2 times A. 2 times 2 is 4. And so I'm just looking to see if I have any factors of 57 that's a perfect square. I probably would have thought that 57 was a prime number, but using my tricks to figure out factors, 5 plus 7 is 12. And there's a trick that says if you sum the digits of your number and it's divisible by 3, then that number is divisible by 3. So I know 3 goes into 57. Which is 19 times And 3 times 19, 19's prime, 3 is prime. There's nothing I can pull out from that radical, so I was just checking. And notice that that's a real number. -5 plus square root of 57 over 4 is a real number, and -5 minus square root of 57 over 4 is a real number. Okay. So we found our solutions.